cumulative frequency. What this question is asking us to do is, for the third time in this exam paper now, is read off a scale of a graph. Okay? So that's in one exam paper, there's been 3 questions where you have to read scales. So you've got to be confident doing that. Okay? So let's start with, before we do anything with the question, let's just check we got the scale right. Okay? Mason. So first of all, between 0 and 20, there's 20 numbers, obviously between 0 and 20, and we're dividing it by 10 squares. Good. So each square is worth 2. And between 5 and 6, we've got 1, and we're dividing it by 10, so each square here is worth 1 divided by 10, which is 0.1. Okay? It's good to do that at the start, because like we said, it's 3 questions now we've had where we've got to look at the scale, so get used to being able to do that. Oh, okay. First question asks us, so see at the bottom there, write down an estimate of the median weight of the 120 babies. Okay? So for this, median is middle. Be careful of this, because I've seen this sometimes in exams. That is the biggest number, but make sure that is actually the highest frequency. Okay? In this case it is, because it says, on the top, okay, it says that the birth rate is 120 babies, and that's 120. Also, that the curve stops there as well. Okay? Just make sure you do that, because what sometimes I've seen is this scale carries on. People just used to see the top number there and halving it, but don't. You look and see where the top of the cumulative frequency is, that is your maximum. You half that. Half of 120 is 60. Draw a line across. You've got to get used to drawing this line across. Where it hits the line, then go down. Okay? And when it hits that, it's halfway between 7 and 8. So the median weight is 7.5 pounds.
What we were tending to do in my last class was some people would accidentally get confused and say the median was 60 because they'd gone across from 60. So on this line we used to write median to identify that as the median line, come off and read off what that value was and say 7.5 on that line, and it was a way of sort of avoiding accidentally saying it was 60. So I don't know if you want to use that. If you like it, use it. If you don't like it, don't use it. It's fine.
Okay, so next question then is asking for an estimate of the interquartile range. So it's quite standard questions are asking you now, the median, interquartile, and then interquartile range. So for this question, it's quite straightforward if you've been looking at cumulative frequency already. So interquartile range, what you're looking for is the lower quartile and the upper quartile. For me personally, I find it better to go for the lower quartile first. If I've got the median, which is halfway, is 60, the lower quartile is the quarter point, okay? So it's half of that again. So a quarter is half of a half. So that's your lower quartile. So here's my lower quartile. I'll go across. At 30. Where it hits the line. I'll go down. I'll do the same way as I just did. So we'll have lower quartile equals. So now we said every little square here was worth 0.1. 6.1, 2, 3, 4, 5, 6, 7. So that'll be 6.7, so lower quartile is 6.7.
So just half 60 is not what you do.
So what I did, to find the median, I halved 120, then I halved that again to get what the lower quartile number was. Okay? To find the upper quartile, once you've got the lower quartile, we're trying to find the 3/4 point. And the 3/4 is just a half and a quarter. So what I would tend to do now is add these two numbers together. 1360 gives us 90. So here is my upper quartile. Or, again, you could think it's halfway between 60 and 120. Draw your line. Okay, so 8.1, 2, 3, 4. Okay, go for it. So my upper quartile is 8.4. Interquartile range, remember range from all the calculations done before is the highest, take away the lowest. So interquartile range is 8.4, take away 6.7. Again, please remember to calculate paper. Okay, so the next question, part C, is asking you to write down an estimate for the number of babies whose weights were greater than 9 pounds. So here's 9 pounds. So we want to know how many babies were greater than 9 pounds. So what we find is we go up from 9 pounds. We're going a different way now. We're going up from 9 pounds. And we go across. Remember what we've got for our scale here. Every little one is worth 2. So 100, 102, 104, 106. So what it's saying from our graph here, that 9 people, 106 people were up to babies were up to 9 pounds. So if 106 of them were up to 9 pounds, how many were greater than 109 pounds? We're trying to find what the difference is between these numbers here.
14.
So 120, thanks Sam. 120, take away 106 equals 14. Okay? Has anyone attempted this question? Okay. So similar shapes, let's go through it quickly. We're going to do a little bit more similar shapes afterwards. There are 2 ways of doing this. Okay? One method looks for how do I get in a similar shape, it's just an enlargement. So when you see the word similar, that is saying that's an enlargement. So we're trying to find what the scale factor is. Okay, what do we times every side in this by to make it this side? So we're trying to find basically how you get from there to there. Okay? So to find that multiplier, what you do is you find the 2 corresponding sides, and you do the biggest one divided by the smallest one. So 24 divided by 6.4 is 3.75. So the multiplier to go this way is times what? What's wrong, Sarah?
Nothing. Wait, avoid.
Alright, so to go from there to there, we times 3.75. To go in the other direction, because now we're going this way. Because we're going in the other direction, and we want this side length here, okay, the question's saying it wants GF, so it wants this side length here. So because from the smallest to the biggest we multiply by 3.75, to go the opposite direction we do the opposite of multiply, which is divide. So our calculation is going to be 21 divided by 3.75. So again on your calculator, 21 divided by 3.75, get you an answer of 5.6. So remember, similar shapes are just enlargements. You find what the enlargement, the scale factor is, and every side will have that scale factor enlargement. There in centimetres. It's good to put the units down, but unless the question says write your units, or it's a QWC question, don't worry too much if you miss that. Okay? Okay, the next bit is an additional step. We're trying to change our area from the smaller shape to see how big it would be in the larger shape. For this, we've got lengths, area, and volume. So when we're going length to length, we times our scale factor. Because what we did above there, we went from a length to a length. So we just multiplied or divided by a scale factor. If we're going from area to area, area is squared. So it's times scale factor squared. If it was volume, it would be times scale factor cubed. So because we're going from area to area, it's 38. Our scale factor stays the same, 3.75, because it's area, oops, and it's going to 3.75 squared. So using your calculator, 38 times 3.75 squared. That gives us our answer of 534.375 cm squared. And again, it doesn't say anything about putting in certain units, it doesn't say anything about rounding it. So you answer like that. Okay? Okay, we'll leave it there for now.